Yes, good afternoon to all my colleagues in India. This is Satyanarayana from Caledonian College of Engineering, Muscat, Oman. I am very much impressed by Professor Krishna Vedala's untiring efforts to improve engineering education in India. I would like to share my 2 decades of industry experience coupled with 1 decade of teaching experience. It is a fact that there is a gap, huge gap between wide gap between industry and institution, and it is also increasing day by day. There is a need to bridge the gap. For example, markets are flooded with nowadays robotics, solar photovoltaics, membrane bioreactors, and sensors, many things. Of course, no doubt, in India, IITs, NITs, and few universities have these technologies in curriculum, and they are working in their laboratories also. Sure. Of course, their laboratories are well equipped with at least instruments and equipments. But in most of engineering colleges and universities, these topics are not covered in their curriculum, and the labs are also are not there in the to meet the students' needs. Okay, this now today my topic is transformation of engineering education in India. So I would like to, what is the main objectives? The objectives is reduce the gap between industry and institution. That is a very badly required. Nowadays, technology is changing at a very faster rate. We have to go along with the technology. That is a basic objective. And again, we have to build the confidence in our students also. They should have confidence to join the industry and to shape the graduates ready for industry. That is our duty. Because finally, our target is students target generally industry only, either software or any other industry. Even nowadays, even they are calling other like business also, they are calling industry also. So you have to make them industry ready. That is the main objective of our colleges or institutions. Okay, now how to transform? So we have to incorporate new latest technologies and developments in the syllabus. First one. See, in USA generally they used to update. They are very fast. Once any technology has come, means immediately institutions also. Or generally they used to develop in the institutions or in R&D labs, and they used to develop into they introduce in the market. They then we have to synchronize our syllabus also with the laboratories. There is sometimes we used to teach theory subject. Well, let us take remote sensing and GIS. I know very well, and most of the universities they have the syllabus are remote sensing and GIS. Because basically I am from civil engineering, renewable engineering. Generally, I used to give examples only from civil engineering and renewable engineering. Okay, then I have seen many colleges also. They have remote sensing and GIS subject is there. Theory class is there, but no lab is there. Simply teaching only theory, I don't think it is of any use for the students. Until otherwise they have some practical knowledge. They should know how to do the GIS mapping and layers and all. At least they should know how to do the GIS mapping. Then most of the another thing is very important is of course Guru Nanak institutions they started already to write the learning objectives for each subject, and what are the outcomes and how to map these learning objectives and outcomes. This was started in 2014, 13, 14 or 13 they started. Very good, they are ahead. And moreover, we should have to some theoretical approach. Mostly our approach is in engineering college. I have seen theory hours are more, practical hours are hardly. There are 6 hours for one semester, one subject. Generally, in semester there have only 2 labs. I think it is not sufficient. It is not sufficient to gain practical knowledge. And mostly, I am not happy with the midterm examinations. For at least graduates and postgraduates, that should be replaced with some industry-oriented project. At least they should have some practical experience. For example, this should be for each and every subject there must be some industry-oriented subject. For example, if I am teaching water resource engineering, I must give a topic related, for example, stormwater drain, flood rain or runoff. How to calculate you to draw a unit hydrograph or any hydrograph from flood waters. This topic I can give instead of midterm examination. I should replace the midterm examinations for this water resource engineering. I should give a topic, find out the water runoff during a storm or any small rain is there. They should be able to calculate how much quantity of water is getting drained from particular place. At least this type of topics should be given, replacing the midterm examinations. Midterm examinations, I don't accept this should not be there in the, at least we should BTech and MTech level, they should not be there in midterm examination. We should give some whatever marks we are giving for midterm examination. That much marks should be allotted to the practical project. They should do for each subject. If they do, they'll get a lot of experience in their BTech level. This is followed for each subject. For example, a drawing. They should use one good AutoCAD and they should draw any other. They should give some, for example, in Hyderabad, any good place is there. They should draw the AutoCAD, the place and area. They should study there. They should go and they should study, for example, Charminar. They should give a practical design with the practical length and width and height and everything. And that is they should give instead of midterm examinations. For example, other examples like any that's software engineers are there. They should be able to do some small software or something. They should do each subject. They should have some practical industry oriented project or project work. That is what I feel strongly. And there are many. Just now in the beginning itself, I told you there are many latest technologies are there. Solar cells and photovoltaics are flooded now. Almost all the markets. Now even to open the doors also we are using sensors. We need not to open the door or close simply by seeing the image itself. The doors are opening. Sensor and remote control technologies are in very highly there in operation. And GIS GPS are for location identification also latest technology. GPS even nowadays even vehicles also they are using the GPS. They are identifying, for example, if you by mobile call the taxi able to identify where you are and they are coming and pick up. That is the technology nowadays. But we don't have any laboratories. We should incorporate this GIS and GPS also in the syllabus, and robotics also generally in the industry they are using mostly in unsafe places. This robotics also should be taught in a subject as a subject, and moreover one laboratory also should be followed. Then only we can do justice to the students. Then software also should be developed. They should have the students should know how to develop the software. And nanotechnology also multidimensionality is growing, even starting from the medicines and cosmetics and solar cells and all nanotechnology is developing. And I don't think we are teaching nanotechnology, but we are not doing any lab in the. Some people are showing the nanoparticles to the students. I don't think it is sufficient. They should be able to do some at least applications with each other using the how conductivity is increasing with the nanoparticles or physical characteristics or how they are changing. That we must show the practically in the lab also. Then only they can do some further. They can improve. Students further they may scope for improvement. So they will develop another new technology based on this what we are showing in the lab. And nowadays this iron will last for another 25-30 years. Then generally we have to depend on plastic or some composite materials. So composite materials already I think mechanical engineering students are studying one, but they don't know how to make the composite materials. At least some lab must be there to show the how to make the composition of with the different resins or fiberglasses and how to make the composite materials and their strength also we have to study how much strength they are getting, what is the composition of different materials, glass fiber or carbon fiber and resins, whatever we are using in the lab, whatever we are using the materials to make the composite of materials. The students should have some clear idea about the composite materials, how much strength they are getting. So, and we compare it to iron or steel. Then again, same thing I want to share with you again. RSGA subject also, they should have some lab session. Robotics must be there for electronics people. Composite materials must be there for mechanical engineering people, civil engineering people, RS and GS, just I mentioned. And software people, CSE people, they have their own choice. They can make wonders. They are doing wonders also. And of course, that will be one another point. Again, I'm repeating. We are teaching this renewable energy, solar energy, wind energy, and all, geothermal and all for electrical engineering people, mechanical people, and civil engineering students. But there is no hardly I did not see any lab with the solar panels, anode and cathode, and photovoltaic cells, and batteries also should be battery connection to store the power. They are using the batteries also. This is not there. At least they should be able to calculate how much power can be generated, the temperature, the area of the solar panel, and what is the temperature. For example, sun temperature is around 30 degrees. What is the output? It's 20 degrees. How much is that output? It is 10 degrees. Even America, like places also, which is cold countries, also they are generating power using solar panels. So this has students should have this experience and knowledge, and so to develop to know the working principles of solar panels. They must know the role of anode and cathode. By changing the anode and cathode, what is the output? What is the life of this? Life also changes. Earlier, this technology is not economically viable because the life of solar panel was hardly 2 years or 3 years. Now the life is increased to even 25 years also. Solar panels. So now mostly everywhere, many people, countries and governments are switching over to solar energy. So that's why the students should have at least strongly say believe that we should have in every laboratory. It's simple. It's not also not at all costly. Also, we should have some solar panels, some anodes. Of course, if you keep some nanoparticle coated solar panels, it's still better, and it should be the terrace solar. That should be kept at some terrace, and they should calculate the output, how much power is generating. And at least they can use for mother in college also for lighting purpose also can use, and both for student purpose and the college also they can have this save the power also using the solar energy. This also I like say strongly to start one laboratory on solar panels and photovoltaics for both electrical, mechanical, and civil students. Then this is also very important. With which direction we are teaching them, what is the outcome. So how we have to define the objectives. So for example, I am teaching one environmental engineering subject. What are the objectives? What they should learn, and what are the outcomes? What student can understand? That is the outcomes. These two should be matched, and mostly after mapping, should continuously to monitor. Continuous assessment must be there. Although we have to cover all the chapters, just each chapter outcome is reaching or not, we have to see. By doing the some other tests also we can know, and mostly we have to do the projects also related to these objectives and outcomes only. Of course, final exam anyhow will cover the continuous assessment is followed. We'll cover the questions from this one. That is also very important. Like without learning objectives and outcomes, just like blind folded, we have which direction we are going, we may not be knowing. This is also very important for me. So again, same story. Teaching our theoretical approach. Mostly, we are spending more time. How much? How do you, for example, 7 into 6 days, 42 hours. In 42 hours, we are taking 6 hours only for laboratories. 36 hours we are spending for teaching only theoretical subjects. Theory we are teaching. I think this is we should reduce at least to 4 hours teaching, and one at least minimum one lab should be added per semester. That is very very important, and we have to upgrade our laboratories. For example, I have seen Renewable Engineering laboratory also. Many people all are conventional methods only. Nowadays, no one is using the conventional methods. They should be replaced. For example, even CODs also there are instruments are there. Simply we put in the sample in the furnace. 25 samples we can analyze within 2 hours. Furnace, then immediately we can cool it and we can keep it in the photometer to read the COD value directly milligrams it is coming. So no conventional like adding sulfuric acid and again digesting the samples and again adding dichromate, again adding back titrating with ferrous. These all conventional methods are not there. So we have to buy these are they are not costly. They are also now available in the market at lower price. So at least we have to upgrade our laboratories with latest equipment. And moreover, there are instruments are there. For example, for spectrophotometer, all types of analysis we can do by using spectrophotometers. And small kits also analysis kits are coming. So environmental laboratory now can be upgraded without any conventional methods. It will save money and time, and more number of experiments can be done in less time. This is not only this one, all laboratories nowadays you can upgrade with these latest instruments and equipments. And that is only in civil engineering also there are equipment like earlier we used to do the strength by compact strength. Nowadays instruments even non-destructive testing also is there. Non-destructive testing by doing this very easy to operate and the values are there. We can take the instrument anywhere, wherever we like. We can do this one. That much is, and meteorology also. And for example, if you want to analyze the air pollution or air pollution in the environment, earlier when I was doing my PhD, I used to spend 24 hours to do the SPM. Only one parameter. I used to keep the high volume sampler for 24 hours. Nowadays, it is not required. For every half an hour, instrument is recording at least 14 to 15 parameters for 10 lakhs rupees. So it is still it is called monitoring station, air monitoring station, weather monitoring stations are there. They are recording every half an hour 14 parameters. At least that can be utilized for the ambient air quality analysis, ambient air quality analysis to assess. And of course, this is how to you have to upgrade all the laboratories. That is every year. That is a must as per the technology. Okay. That's on midterm examinations. This should be replaced. With replaced midterm examinations with industry-oriented project work, we should have a practical field work. So this I think immediate attention is required. An institutional product. Finally, the output must be the student. The quality of the student depends upon the quality. If the quality of student is good, our institution is a good institution. A civil engineer should be able to design and construct a good building independently. He should know the how to calculate the foundation and how to calculate the beam shape and dimensions, beam and columns, how to design a slab, and you should be able to design with all load calculations how much load it can take, and this should be done by a civil engineer. You should be able to, for example, environmental engineering, you should be able to. Environmental engineering, lot of differences there. Here we are teaching in classes, we are teaching only conventional methods, like screens and followed by then first screens, then oil separation tank, then followed by sedimentation, then we'll say aeration, aeration after aeration, coagulation. After coagulation, we will say clarification, then filtration by sand bed and all. Now all these are replaced by when they are in nowadays latest technology. Most of the industries they are using membrane bioreactors. Membrane bioreactors. They are time consuming. They are spacing. They are time consuming. Time is saved and place is saved. Place also saved and the efficiency also more and quality of the water also very good. So with so many benefits. So simply if you teach the student the conventional method of treatment of water, wastewater or water by conventional methods, by old method like 10 years old, 15, 20 years back also, same technology. Nowadays in the market we have membrane bioreactors. Of course, membrane technology also it is there. In some industry they are using, but membrane bioreactors are widely used in most of the countries, particularly in the Gulf, they are using only membrane bioreactors. So, for example, if somebody wants to work in the Gulf, we don't know how it works. So he should put a blank face while he's exposed to this work. Of course, he pick up shortly, But we should teach in the class, instead of old type of methods. We should upgrade our syllabus as per the latest technologies available in the market, and we should teach them in the class so that they'll increase in the interview also increase the fund. For example, somebody is treating the water using a membrane reactor. He'll ask the question only on the membrane reactor. He will not ask you how you are doing the calculation or how doing the aeration. He will not ask you not what is the principle behind the membrane bioreactor. And this sort of questions only he'll ask. He expects that his employee should have the basic knowledge of what equipment he has in the industry. So that is a necessity. And, computer engineer finally student should be able to develop a software of his own, have a website of his own. That is very much important. And electronics engineer also should be able to operate and maintain. Nowadays, sensor technologies or remote technologies, many are there, even robotics, all are there. It should be electronic engineers should be able to operate this equipment and technologies. It should be able to how to assemble at least to develop the instruments. Also should have electrical engineer also should know nowadays all underground cables also coming, and you should know how to generate the power and how to synchronize with the grid. For example, somebody wants to start a power industry. He'll start a power generation is okay. Then how to synchronize with the grid? That is very important and most crucial part also. We should have some basic knowledge of synchronization with the grid also is very important. And the mechanical engineers should be able to design a boiler. Nowadays, there is no industry is there without boiler. Just like a house without cooking stove, the house there will be no house will be there. Like, just like that, without boiler, no industry is there. For steam generation, for many purposes, they require boiler. So, as mechanical engineer should be able to design a boiler, how much quantity of what the area volume water required and what the pumps will be used and how much quantity of steam will come and what are the losses, how much loss, how to minimize the losses. And you should have some basic idea about the IC engines also. You should have some engines. And nowadays, industry people will see nowadays profitability, productivity, and how to improve their productivity, how to increase their profitability, and how to minimize the losses. These are all generally every institution or every industry, mostly every industry targets. They have fixed targets. What is 3 months target, 6 months target? Not like 1 year or 2 years. Earlier we used to have 1 year targets. Nowadays, most of the industries they have targets for 3 months only. They have they have quarterly targets. So we have to meet the target. To meet the targets, sometimes they are not hesitating even to change the technology also to meet the. Because the competition is there from all over the world. Now, world become a global village. The products are the other companies. They are dumping them on their products at cheaper rate. So domestic product, the domestic market, they are in the stress to compete with the international products. So this is another challenge for the industry also. So that's why they are maintaining always continuously. They are upgrading their technologies. Nowadays, this oil slump, due to suddenly there is a crude oil rates fallen down to $40 something like that, nearly $40. So to make up the loss, they are switching over to solar energy. So what immediately they have taken on a hardwood basis. This is how industry is working. So our students should be ready for industry. Means to, at least it's our responsibility to make them ready for the industry. This is what I want to say. Thank you very much. Any questions, please? Hello. Hello.
Yes, sir. We are waiting for questions.
Okay. General topics are why to repeat again. That's why I made it short. Most of the people knows they have their own targets, and most of the colleges also now they become serious because they are also competition from other colleges. So they are also trying to upgrade their own labs and all these things.
Just one comment, sir. Transformation in engineering education requires autonomy to technical institutions.
Autonomy. Yes, sir. Autonomy, of course, it is true. If they become autonomous, also they'll become independent to develop their own labs and their syllabus and curriculum. I'll agree with that. That is also one of the best option.
What is multidimensional software development?
Multidimensional means, for example, we are using now cell phones development. Cell phone technology software is different. So we are using for even small screens also for computers. We are remote in GIS person is different. For example, for surveying nowadays we are using software also. Earlier we are using for surveying only chain and cross stop. Now we've made it a total station. It is also software. Cell phone has a software, business software, and railway reservation is a software. First and even video conferences is different software. Multinational is different types. We are not using. Earlier it was related to only business and industry. Nowadays, everywhere, even for doors opening, also the software is there. And if you want to call one taxi, the software is there. And GPS one software is there. Location identification software is there. This is different. This is called multidimensional means different directions, different ways of software, not one software. For books also, for example, if you want to develop, if you want to read the book, even not only books, even sets also for any mails, different types of apps are coming nowadays. Apps also, if you download the apps also, different items can be downloaded. Even purchasing also we are doing online. And if you go to any shop also, simply by putting the barcode also, it is able to identify the item and the price also is displaying. That's also one software. It's all software everywhere we are using. For even grocery shops to even space softwares are there. Now without software, now we cannot imagine the life.
You're saying that changing and converting lecture hours to lab hours requires autonomy.
Yes, sir, because autonomy is, they should have freedom, sir. I should strongly feel that generally universities should have the freedom to develop their own syllabus as per the. For example, I see I'm very happy to see that energy and universities there in the where Dehradun, I think, Petroleum Research Institute. University, they are changing differently as per the demand. They are changing the MTech post graduation levels. Their curriculum also they are changing. They are designing their own syllabus. They are designing their own labs. They are updating their yes, they are observing what is the demand, which area have more demand. Accordingly, they are changing their postgraduate degrees, MTech level. MTech, there are new courses they are introducing in the syllabus in the university. So they are upgrading, they are at par. I feel like this. Everyone should have that freedom to have their own syllabus as per the industry requirements. Their target is industry only. Whatever industry is required, they are doing. Uh, that petroleum industry, petroleum energy institute, university, they are doing as per the requirement of the industry. They are designing the new courses. That's the best example. Mostly engineering is not practical oriented, sir. It should reduce the theory hours. It should be more practical. Generally in US, generally hardly they used to spend very few hours in the theory hours, theory classes. Mostly they used to spend their time in the labs only. Then only the students will get hands-on experience. They can get confidence also. If they work with their own hands, they will not forget.
How to overcome gap between industries and institute? Where is the major change required?
Fine, sir. This is it is widening, sir. Because now industry wants mainly profit. They'll say how this year, this month, how many crores we got the profit, and next again that one next quarter how much is the target. So accordingly, they are changing the technology. They are minimizing the cost and improving the quality. They are working multidimensionally. One side, they are improving the quality of the product. If they don't improve the quality of the product, they will not be in the market. They are also minimizing the cost. They are using the technology. For example, mostly solar based and other energy sources and other facilities. They are creating the employees also to minimize the minimize the out cost. So mostly they how to again develop the byproducts. For example, they want to reduce the waste. Earlier in the phosphoric industry, gypsum is a waste material, it's a byproduct. So nowadays, the gypsum they are using to make the cement also. So they, to make the ready to make to use it as a byproduct, they are washing the gypsum and sending to the cement industry. Earlier, iron steel industry, the waste is dumped in the outside as a solid waste. Nowadays, the solid waste also they are making a primer. Small paint industry will also taking that waste material. They are making a primer also. So like this industry, what they will do? The waste minimization by converting the waste into a byproduct and increasing the quality and by reducing the costs also, they are increasing the profitability. For example, here refineries immediately to reduce the cost of the production of petrol production, they switch over to solar energy. So they are not using even though they have plenty of gas here, they are not using the gas for generate power. They are using the solar energy. Because solar energy is almost 10 months available per year. So that's why how it also continuously in the industry they used to do the research. The projects will be there to minimize the cost, to increase the profitability. It's continuous work in the industry. I was there in the 20 years, I was there more than 20 years. We used to work always. We brought down sometime 9 crores losses, to 2 crores. Because our raw materials are imported from the American, USA and other Tunisia and Jordan. Rock phosphate used to uh, um, import from Tunisia, and we used to get ammonia from America, and other phosphoric acid, and all we used to get sulfur also from other Gulf countries. So these are all foreign materials, imported materials. So last will be the source only. So we have worked out at least 4 years, 1 year, more than 1 year, we worked, we brought down the losses. Ammonia is highly to evaporate very quickly. So we have to maintain the temperature minus 30 degrees centigrade to keep in the liquid state. So again, before making the fertilizer. So generally ammonia losses will be more. So they will have developed some technology to reduce the losses and again to recycle the wastewater again back into the process. How we reduce the losses and we reduce the losses from 9 crores to 2 crores. So this is all continuous work for every small thing also related to this waste industry. So that's why we always see the profitability only, profitability, waste minimization, and byproduct development. This will vary from industry to industry. Conditions also will be different, and size of the industry also will be different. You can see, for example, let us take software industries. Software industries, the software yesterday's software is outdated for today. See, cell phone is the best example. How many models are coming per day, in 1 year? So they're upgrading the technology. Best example is your cell phone. For 10 years back, I used to carry a cell phone of around 300 grams of cell phone. Nowadays, it is hardly 20 grams, 25 grams cell phones also there. It's many number of features. Earlier, we used to make only call, incoming call, and outgoing call. Now, how many features are there? Even as like PC, it became like a PC. And we are able to video shooting also. We are doing pictures also. We are recording everything. So many facilities are coming. See, within 10 years, is how technology has changed in the cell phone itself. The best example. So how industries are working, even cell phone industries. The best example is what we can take is cell phone. And same concept is now applied. See now Nokia, to overcome the water features Nokia have, to improve the Samsung again further improve, and it has taken the market. Samsung. Like this competition also there in the market for the different companies also. So they are struggling. For example, now Nokia is down because the software is not user friendly. So whereas for the Samsung, the software is user friendly, now most of them are again switching over to Samsung. Like this, how the features, what features are using, what are the friendly, user friendly, and cost and all. Cost also very important. For example, if I make everything available, if the cost is very high, no one will purchase. I have to see the cost, features, and competition also. So they are continuously they will be working to upgrade their mobile phones or anything. Mobile phone is the best example how they are doing research. Really, is a great achievement. Cell phone technology.
Thank you very much, sir. Those are all the questions.
Thank you, sir. Thank you, sir. Thank you, sir. Thank you very much, sir. Thank you.
Have a good day.